Right, the last video of our bonding summary. This will be quite a quick one, I think. So far we've done ionic, metal giving electrons to a non-metal, covalent, two or more non-metals sharing a pair of electrons. And that led us to simple molecules like methane, but there's also giant molecules where the covalent bonds go throughout the entire structure. Our last type of bonding is the easiest one, save the easiest till last. Okay, first off, it is metals only. So it's metallic bonding. And what we have here is a description of it. It is metal cations surrounded by a sea of delocalized electrons. Okay, so cations. Cations are positively charged ions. Let's put that one up there. Ions. Let's put that there. Positively charged ions. Okay, and these metal cations are regularly arranged. By that I mean a neat and tidy arrangement. So let's put that at the top there. A regular. I should have put that in at the start really. A regular arrangement of metal cations surrounded by a sea of delocalized electrons. We don't need to do any examples of that because they're all fairly similar. So let's just go straight down to this box down here, this row down here, which was structure. Let's draw what this sort of structure looks like. So a regular arrangement of metal cations, so positively charged ions. So these were the metal atoms, and they became ions because they gave electrons away. Okay, an electron is negatively charged. So if this gave an electron away, it ended up being positively charged. These ions end up being positively charged. So these are our metal cations. And what you'll notice here, I'm drawing rows and rows of metal cations. And they're kind of like arrangement. I'm trying to, if my diagram is in any way good enough, this will look like bricks in a wall, sort of like alternating on top of each other, rows alternating on top of each other like so. So like bricks in a wall have cement joining them. Well, the cement here is these electrons that these cations have given away. So the metal atom gives away an electron, but the electron doesn't go very far. It simply sits between the layers of these things. So what we have is positive, negative, positive, negative, positive. So we have a high melting point. A high melting point. This row here was melting point. Just to remind you, we've looked at physical characteristics of melting point and electrical conductivity for ionic, for covalent, and now for metallic. So we have to talk about the melting point and the electrical conductivity of metals, and hopefully the structure here explains both of them. High melting point because we've got opposite charges, the positive ion, the negative electron, because opposite charges of metal cation, which was positive, and electron, which is negative, require a lot of energy to separate. So hopefully you're seeing a theme to melting points now. When we discuss melting points, we say, look at the structure. Is the structure easy to separate or hard to separate, and if so, why? Metals, hard, oppositely charged ions strongly attract. Giant molecular, hard because we have to break bonds. Simple molecules, easy because there's nothing holding the molecules together, weak forces of attraction between molecules. Ionic substances, hard because the oppositely charged ions strongly attract. And then we say it requires a lot of energy or a little bit of energy to break it apart. So it's a lot of energy if there are strong bonds or attractions, and a little bit of energy if there are weak bonds or attractions. Metals, strongly attracted, positive, negative, positive. Electrical conductivity, yes. Okay, let's go back to what a current of electricity is. A current of electricity is a flow of charged particles. What charged particles do we have here that can move? Not the cations, they're held in place, but these electrons, these can move. Yes, because delocalized. Delocalized means electrons that are free to move. Delocalized electrons can move. Last row was about solubility. Metals are not soluble in water. And there is our bonding summary. Now I will guarantee pretty much that, I don't know how many marks, 20 of your 100 marks on a standard GCSE paper, the answers to those marks are on this double page spread. This is the most important page that I have ever created, and it's the most important page I ever teach every year. If you don't learn anything for your exam apart from these answers, learn these answers.